This is general biology. This is chapter 1. Chapter 1 begins on page 4 in your book, and it asks, what is science? What is science? And many people think, oh, I don't know what science is, or they think they know what science is, or you may think that you're not very good at science. But what is science? Science is a way of knowing. And there are certain ways to know things. People say, well, how do you know that? Well, scientifically, and when you start that scientifically explanation or definition, we have to refer to a certain process. Science is an organized way of gathering and analyzing evidence about the natural world. And when you take a look at science, really, one of the key words here, it's an organized way. Okay, and when we say way, we mean really it's a process. So it's an organized way. We've got to be organized, and that's what we're going to show you how to do. And it says of gathering and analyzing evidence. So the piece about evidence is this is information or things that we can see, touch, feel, smell. This evidence, things that we can sense about the natural world. You'll find on page 5 where your book describes science as a way of knowing. And it says that it's an organized way to gather and analyze evidence. And you may ask, Mr. Hollins, how can I get organized and take a look at some evidence, gather some evidence and look at it? And we're going to teach you how to do that. That will be one of your skill development lessons in this class for general biology. Also on page 5, it talks about the goals of science. It says one goal of science is to provide natural explanations for events in the natural world. And that seems reasonable. We want things explained because we have questions. Additionally, it says, science aims to use explanations to understand patterns in nature and to make useful predictions about natural events. Now, these useful predictions, this is really what we hope that science does. The explanations that we come up with should be able to be used to make predictions. If they, at some point, no longer are able to make predictions, then we get rid of that evidence and we revise our definitions or our body of evidence. And then once we get an agreement with the scientific society, then we can form things like laws and theories. When you read page 5, take a look at the vocabulary section here. It's a little caption on the side of the page that said word origins. The word science derives from the Latin word scientia, which means knowledge. Science represents knowledge that has been gathered over time. The last paragraph on page 5 reminds us that science changes. Science changes because evidence adds up. And as this evidence adds up, we have new questions. And so uncertainty continues because we continue to have new questions that we would like to continue to have information to try to make explanations and therefore revise the science behind explanations and natural events. Additionally, it says here that you may be surprised to hear this, but science rarely proves anything in absolute terms. Scientists aim for the best understanding of the natural world that current methods can reveal. But uncertainty is part of the scientific process and part of what makes science exciting. So keep this in your mind. Science never tries to prove anything. It only attempts to explain the meaning of the evidence that we gather. Take a look at page 6. You'll see where it says scientific methodology. This is really the heart of science. It's what we do. And we're going to explain this methodology to you and tell you about some experiments that take place and also have you design a few experimental examples of your own. Scientific methodology involves observing and asking questions, making inferences and forming hypotheses, conducting controlled experiments, collecting and analyzing data, and drawing conclusions. Even little kids often make observations and they ask questions, and this is one of the easiest things to do. Inferring and making hypotheses is the next step. We do this often when we say, well, if you sit too close to the polar bear cage, they may reach out in between those bars and grab you. And then somebody may make a hypothesis and say, oh, he'll tear your head all the way off, or he may just eat your limbs straight through the bars. we often do this inferring and making hypotheses. So this is also a natural tendency for you to do, and this is all part of science. Designing controlled experiments. This is the next step, and this is where we start to organize and really document what it is that we try to answer, what question we try to answer. Designing a controlled experiment should take some observations, ask some questions about it. You may informally make some inferences or hypotheses about it, but when you design this controlled experiment to test your hypothesis, this is when we have to start to write things down. Part of designing a controlled experiment is determining an independent variable. And that is the variable that is deliberately changed. So the things that we make different, that's the independent variable. We also have the dependent variable. And the variable that is observed and that changes in response to the independent variable is called the dependent variable, also called the responding variable. And this is all on page 7 in your book. So read that section and copy these notes and make sure that you have agreement and understand what you're reading. Typically, an experiment is divided into control and experimental groups. A control group is exposed to the same conditions as the experimental group, except for one independent variable. And finally, we have the experimental group. And the experimental group will be the group that you change one variable. You add an independent variable here, and we like to see what the outcome will be. Read the scientific methodology description on page 6 and 7, and prepare any questions you may have. We will talk about collecting and analyzing data and drawing conclusions when we meet in class.